Hi guys, here is MIH. I know it had been a really long time of 3 months since my last video, and that is because I'm writing a bunch of university application essays. Most of the results will come out soon in March, and now I finally got some spare time to restart my lab projects, the ketene lamp being one of them. Anyways, a quick recap on the ketene lamp project. Last time, I attached the filament directly in the flask containing acetone, and the heat overloaded the reflux condenser so large amounts of acetone ended up in the receiving flask. According to suggestions in the comment section, the usual way of avoiding this is to set up two condensers in parallel to fully condense acetone and place the pyrolysis zone away from the boiling zone. A good demonstration of this setup is Doglav's video. However, it is a really huge apparatus, quite difficult to assemble and clean, and I simply don't have that much glassware available. After a few trials and testing, I found a new approach that does not require two condensers. In fact, it is basically a regular distillation setup, which is much easier to construct and run while offering basically the same performance of removing acetone efficiently. I also found a robust and convenient heat source, a stainless steel heating rod, to replace the weak and thin nichrome wires I used last time, so the lamp may run reliably. This design of using a rod-like heater was inspired from one of the ketene lamp papers sent me by Greg Wally, so here's a very big shout out and thanks to him. Still, I did encounter some difficulties during the runs and cannot make a lamp operate continuously for long, so that's why it almost worked, but still didn't work completely. But anyways, I believe I'm extremely close to getting the lamp to work. Let's see how the apparatus is designed. As I said, it is essentially a regular distillation setup but modified slightly. First, in place of the usual thermometer, I place my heating element, which is a stainless steel rod used to ignite biofuel or coal in commercial furnaces. As I found in power testing, once connected to power, its lower parts can reach up to 800 degrees C, which is perfect for pyrolyzing acetone to ketene. It is sealed to the apparatus using a silicone stopper, and as you may guess, this seal was what repeatedly troubled me later on, since the heat from the rod basically destroys any stopper I place here. The other adaptation of the setup is a 20cm tube between the distillation head and the condenser, serving to cool the hot gas significantly and make sure the condenser could then condense most of the acetone in the receiving flask. The end of the distillation adapter is filled with a glass tube that has a bubbler stone attached to enhance gas absorption. And yes, the glacial acetic acid solidified in the cold weather, proving that it contains basically no water. As the acetone vapors enter the distillation head, I start the heating rod. Gradually, we can see the liquid acetone in the distillation head disappearing due to the rod's heat. After a minute, the rod reaches our target temperature to start pyrolysis, and white fumes containing ketene and other products begin to appear. The rod continues to heat up, and the pyrolysis becomes much faster, as seen by the dense fumes in the glass tube and the condenser. Acetone begins distilling rapidly into the receiving flask, and many bubbles are seen in the beaker. A few minutes later, the rod becomes red hot, and the pyrolysis runs smoothly. However, only a split second after, the silicone stopper disintegrated due to the heat and started burning. Silicone turns to silicon dioxide when it contacts the red hot rod, widening the hole in the stopper, so the rod starts to slide downward and burn through. After the rod cooled, I inspected it to see that a layer of silicon dioxide crust coated it, which easily flakes off. Honestly, I was surprised that the silicone stopper could hold for so long in the heat, but still it could not be used for hours. I attempted to fix the rod in the stopper using a clamp, but after 10 minutes the rod burned through again. I then tried two more types of stopper materials, namely rubber and foamed silicone, but none of them withstood the heat better than the original silicone one. So yeah, I don't have many options left on this. But then one idea emerged in my mind, to use the glass adapter that we used in the first version of the lamp. It turns out that the rod basically fitted in the adapter, and although it wasn't a perfect seal, I still gave it a try. And confirmed, the adapter did manage to withstand the rod's heat, but the seal was leaking quite heavily, and some white glass is released from the top. I tried sealing the adapter with Teflon tape, parafilm, and food wrap, as well as adding a layer of aluminum foil between the rod and the glass. And apparently, the food wrap approach managed to control the leak to an acceptable level. Still not perfect, but the gas generation is now steady, and the apparatus can finally run on its own without me having to guard over it. However, after working for 15 minutes, my power switch had tripped, and after inspecting the rod, I found that its interior had a short circuit. My best guess is that the acetone and acetic acid corroded the wire connections at the top. With the rod broken, I cannot restart the lamp, so I distilled off the acetone and acetic acid and saved them for the next attempt. Unfortunately, I didn't isolate any quantity of acetic anhydride from these runs, as the lamp still didn't run continuously for a long enough time. But still, this attempt was extremely close to a success. The pyrolysis temperatures reached, the condenser worked efficiently, the gas absorption was rather complete. And above all, this new apparatus design proved to be much more convenient than existing ones while also having a great performance. What remains to be solved is the problem regarding the seal, but just after the experiment, I had a new idea that is probably going to work. I can stack two distillation adapters vertically together, pass the heating rod or nichrome wire vertically through them, and connecting the wire using a large copper sticks that I used in my first lamp design. This could eliminate the need for stoppers that maintain good seals even at a very high temperature, and possibly could increase the length of the pyrolysis zone for a more complete and faster reaction. If you guys have any ideas or suggestions, I'm more than happy to hear about them in the comments as usual. See you soon!